Hi everyone, in this video we are going to see the gate questions with solved answers for the year 2023 and from the subject data structures and algorithm. It is part 2. Please subscribe my video channel for getting part 1. In this part 2 video we are covering 2 questions. Question number 1. An algorithm has to store several keys generated by an adversary in a hash table. Here the adversary is malicious who tries to maximize the number of collisions. Let k be the number of keys and m be the number of slots in the hash table and k greater than m. Which one of the following is the best hashing strategy to counteract the adversary? So here somebody is creating a malicious, creating the hash function so that they are maximizing the number of collisions. We have to find a best hashing strategy to reduce that number of collisions. So the options are given as division method. The division method that uses the hash function h of k equal to k mod m. Here k is the key and m is the number of slots. So in division method it uses the key, the value key for hash function. Usually if we are using the key values for hash function, there will be a worst case possibility that all the keys are hashing to the same location. In such case, there will be a possibility of increasing the number of collisions definitely. So in this method they are using key value. So there is also a worst case possibility of having all the keys hashing to the same location, thus generating number of collisions. So it will not be the best hashing strategy. Next option is multiplication method. Again it uses the hash function h of k equal to m into ka minus ka, where a is some constant. Here also they are using the key value for multiplication method. So there also a worst case possibility of hashing all the keys to the same slot m, and there will be a chance of increasing the collision, not reducing the collision. So we cannot counteract the adversary. This is not the best hashing strategy. Next one is universal hashing method. In universal hashing method, it will choose the hash function randomly. The universal hashing method will choose the hash function randomly. It will not depend on any keys. So there is a possibility of reducing the number of collisions. As in case if we use the keys, there is a possibility of increasing the collision by hashing all the keys to the same slot. As here in universal hashing method, we are generating the hash function independent of keys randomly without depending on keys. So there is a chance of reducing the number of collisions. So this might be the best hashing strategy to counteract the adversary. And option D, here also if k is the prime number, use division method or multiplication method. So again we are using the value of key. So it is a prime number or any other number. If we have so many prime number means all those keys hashing to the same slot means there is a collision. There is a possibility of increasing the collision. So again we are increasing there is a worst case possibility of increasing the solution if we are using the key values in hash function. So the best hashing strategy is universal hashing method. In detail, for a worst case in hashing function, in hashing strategy, in worst case there is a chance of all keys hashing to the same slot leading to O of n. So this is the worst case. For best and average case, choosing the hash function randomly, that will be O of 1. So for best case, we have to use the universal hashing method, which will choose the hash function randomly without depending any keys. So the answer is option C. Question number 2. Let A be a priority queue for maintaining set of elements. Suppose A is implemented using max heap key data structure. So here we are using max heap tree. The operations extract max of A, extracts and deletes the maximum element from A, Operation insert A comma key inserts a new element key in A. So two operations are happening in max heap tree. The properties of a max heap are preserved at the end of each of these operations. After extracting, and that is after deletion operation also, we have to keep the tree as maximum heap tree, and after inserting an element also we have to keep the tree as maximum heap tree. So when A contains n elements, which one of the following statements about the worst case running time? The two operations is true. We have to check which one is true. So here we are having two operations: extract max of A, insert A comma key. We are deleting one maximum number and inserting a maximum number. Inserting a number. So for both operations we have to maintain the maximum heap tree at the result also. After deleting the maximum element from A, we have to make that tree as maximum heap tree, and then after inserting an element into that maximum heap tree, we have to maintain the tree as maximum heap tree. So first let's take extract maximum of A, that is we are going to delete the maximum number. In a maximum heap tree, absolutely the root node will be the maximum number. So we are deleting this. Let's take this as a example maximum heap tree, and we are just doing extract max of A function, that is we are going to delete the maximum number from this tree. So we are deleting the number 10. For that what we will do, we just move this root node, the maximum node 10 to its least child node, and then we will delete it. So we are interchanging this node 10 with 5 and right side, and we are deleting this 10. This is check 1, order of 1. And then we have to keep the maximum, keep this tree as maximum heap tree as it is. So for that what we have need, we have to change it, make the tree as having the root node as maximum number when comparing to its child node. So here 5 is smaller than 6. So we are interchanging this in these two nodes. So it will become 6 and 5. Then again we are checking this tree. Here 8 is greater than 6 root node. Root node is smaller than the child node. So we are interchanging these nodes. 5 and 8 are interchanged. Now we check this is the maximum heap tree. So after deleting the maximum number, we are maintaining the tree as maximum heap tree. So we are interchanging the nodes. It will take order of log n. Many steps. So log n. So for extract maximum of A function, for deleting operation it have order of 1, and for maintaining the heap function, that is max heap p5 function, maintaining the tree as max heap tree, we are having order of log n. Next is insert A comma key. Now we are going to insert a number. So let's take another example. Let this be the example tree, and we are going to insert number 10 in this tree. For that we have what we will do, we will insert at as a child node. So here at right side we can insert it. Right side we are inserting the node as 10. So for this the order is 1. For inserting it takes order is 1. And for after that what we have to make it as the maximum heap tree as it is. So for that we are checking, no, 4 is smaller than 10. So what we will do, we will interchange those nodes. Again we check, is this the maximum heap tree? No. 7, root node is smaller than its child node. So we are interchanging these nodes. Now check, this is the maximum heap tree. So here it takes some steps. So that is order of log n. So for inserting we have order of 1, and for making after inserting to make the tree as a maximum heap tree, it takes log n. So both extract max of A and insert A comma key run in order of log n is the answer. So option B is the answer. Thank you for watching this video. Please subscribe to get more gate solved question papers. Thank you.